Binary search is the algorithm every programmer should know cold. Today we'll see what it does, how it works step by step, the classic iterative implementation, why off-by-one errors are notorious in binary search, Python's bisect module, and finally, when binary search is the right tool, and when it isn't. Imagine you're looking for the number 23 in a sorted list. You could skim left to right, but that's linear O of n. Binary search is smarter. It uses the fact that the data is sorted. Look at the middle element, then throw away half. The right half if your target is smaller, the left half if it's larger. Repeat. Each step cuts the problem in half. The algorithm is simple. Keep 2 pointers, low and high, bracketing the search range. Compute the middle. If the middle is your target, you're done. If the target is smaller, move high to mid -1. If it's larger, move low to mid +1. Repeat until low passes high, meaning the target isn't there. Log base 2 of n steps. 20 steps for a million items. Here's binary search in Python. Notice low and high are inclusive. Both endpoints are valid candidates. The loop runs while low is less than or equal to high. We compute mid using low plus high minus low divided by 2. That's a small trick to avoid integer overflow in languages where it matters. When the target isn't found, we return -1, a common convention. Binary search is famously hard to get right. The most common bug is the loop condition. Is it less than or equal to? Off by 1. The next is updating low and high. Do you set them to mid, or mid plus, or -1? Get it wrong, and the loop never terminates, or skips the answer. The fix: pick one convention and stick with it. Inclusive bounds and mid plus or -1 is what I use. In Python, you almost never write binary search by hand. Use the bisect module. Bisect_left returns the leftmost position where you could insert a value and keep the list sorted. Bisect_right does the same for the rightmost. Together, they handle the leftmost occurrence and rightmost occurrence variance for free. Insort inserts and keeps the list sorted. Production grade, written in C, fast. When should you reach for binary search? Use it on any sorted random access structure, arrays, slices, columns of a database. Use it for any problem where you can decide too high or too low on a guess, even non-array problems. Avoid binary search on linked lists. Random access is O of n there, so you get nothing. And avoid it when the data isn't sorted and you can't afford to sort first. Binary search looks deceptively simple, about 10 lines of code, but it's one of the most useful algorithms you'll ever learn. Master the off-by-ones once, and you're set for life. Next up, recursion. The technique behind every divide-and-conquer algorithm we've covered so far, and how to write it without blowing the stack.